Okay, welcome to Quadratic Functions Review. So just a reminder, we have a unit test on Monday. So we're going to be just reviewing some of the elements of quadratic functions, and then we're actually going to be doing our next unit is more so looking at quadratic functions. So we're going to use the graph on the right there to look. So graph A here, okay? So if we're looking, this is our origin here, okay? We're looking at the vertex where 1 and 1, 2, 3, 1 and 4, okay? The direction of opening is down. Our y-intercept, so where it crosses the y-intercept, is 0 and 3. And then we have two x-intercepts as well. So if we look, so we have -1 and 3 in this situation. Okay, and those aren't points, those are just, so if I were to write them out as points, it'd be -1 and 0 and 3 and 0. It's just the chart won't let me. So if we're looking at graph B, okay, its vertex is down here, so it's -1, -9. It's opening up. It has a y-intercept of -8, so 0, -8. And it crosses the x-axis at -4 and 2. So again, those are just being able to read the parabolas right here. So first and second differences is from our first day. So where we take 3 and subtract 4.6, and we get a value of -1.6, 1.8. So you're always taking the value there and subtracting it from the previous value. Okay, 1.8 minus 3 is -1.2. 1 minus 1.8 equals -0.8. 0.6 minus 1 equals -0.4. 0.6 minus 0.6 equals 0. So what you'll notice is there's no common first difference, so it's not linear. So then what we do is we move to the second differences, and we see if there's a constant there. It's -1.2, subtract -1.6. That actually becomes addition, so we get 0.4. -0.8, subtract -1.2, we get 0.4. So if we keep working through this math, we keep getting 0.4 here. So we keep getting a constant. So therefore, we know it's a quadratic. And that's just what this is saying down here. The table above shows a quadratic relation. So again, at any time, stop the video, try questions, go ahead. So state the y-intercept and the direction of opening for each function. So it's when you're looking at these equations, the direction of opening is always the A. So a positive means it's opening up, okay? A negative means it's opening down, okay? And the y-intercept is pretty easy. You're just looking at the last value. So we know the y-intercept is 0 and -8. And in this situation, it's 0 and +11. So right there, you can already just sketch a little diagram because you know what the vertex is and you know it's opening down. or like that. This is opening up. Okay. So the next part is finding the x-intercepts. And when we're finding the x-intercepts, it's about pulling out the x's. So for example, we know that it's x equals -2 and x equals -9, okay? And then to find the axis of symmetry, you add those two values up and divide by 2. So -2 plus -9 is -11 divided by 2. So we find out that the axis of symmetry in this situation is -5.5. Okay. So some of these you'll have to actually do another step. For example, you'll have to factor. So that's why the last unit was so important. So we have y equals negative, and then we're going to factor. So we're looking for two numbers that multiply to -27, but add to -8. So if you're thinking, so that would, the criteria would be x minus 9, x plus 3. So once you factor it, then you can find out that x equals 9 and x equals -3. Then to find the axis of symmetry again, we add those two values together and divide by 2. So 9 plus -3 is like saying 6 divided by 2, which is 3. So the axis of symmetry, so where it's reflective of the parabola, is at the y-intercept, y of 3, okay? So the last one was simple trinomial factoring. This one, you would start with common factoring. So I can take out the 2 first. I'll be left with x squared minus 81. And then what I would do is difference of squared in this situation. So it'd be x minus 9, x plus 9. So I find out that x equals 9 and x equals -9. So when you get two values that are same for the axis of symmetry, so you get 9 plus -9, you're going to notice that they just become 0. So if you notice that right from the beginning, then you don't have to continue on. So 9 plus -9 is 0. So this parabola actually hasn't shifted anywhere. Okay, so I'll do one parabola in one color and the other in the other, okay? So the first thing you might want to notice is like, what's the y-intercept? Okay, so the y-intercept, okay, is going to be 0 and 15. You're just taking the c value, okay? So 0 and 15 here, okay? We also know it's opening down because of the negative sign. Next, I would factor this. So y equals negative, and I'm going to factor. So I'm looking for two numbers that multiply to 15 but add to -8, which is x minus 5 and x plus 3. Okay. So the next thing here is to look at x equals 5, x equals -3. So I can graph those points because that's where it crosses the x-axis. But what's also important is you have to use that axis of symmetry to actually find out where the true vertex is, because you found out where it crosses the y-intercept, but you're trying to do more here. Five plus -3 divided by 2 is 1. So we know that the axis of symmetry occurs here, okay, at 1. So there's one more step. You have to plug 1 back into the equation to find out the top there, okay? So if you plug 1 back in, it'd be like 1 squared is 1, 1. So when you put 1 back into the equation, you'd end up getting -4 times 4, which is 16, and 16 times -16, and -16 times that would give you positive. So you would have enough information to graph the following parabola, just like that. Okay, I want you to try the next one by yourself, and then unpause the video to go through it. So in this situation, there is no movement. So that's because your y-intercept is actually your vertex as well in this situation, okay?